Next one. Very common problem to find in any math class. I actually had a professor in college who was painting his house, and he was up on a ladder, and the bottom slipped out, and he fell, and hurt himself pretty bad, actually. And he was telling us about it when we got back into school. You know, it happened over the summer break. And just kind of coincidental that he would have a math professor fall off a ladder. And just saying, got to teach you these problems, you know. I think we all, including him, realized it was a heck of a coincidence. And a little bit funny, to be honest, since he wasn't dead or anything. He just got hurt. Alright, so here's what's going on. I've got this ladder. It's 20 feet long. It's leaning up against a wall. Forms a right angle. So we got a right triangle here. It says that the bottom is moving away at a rate of 2 feet per second. So if we call this x, then the rate at which it's moving away would be dx dt, is 2 feet per second. That means that up here, I'm going to call this side y, and this one's moving downward, right, at dy dt, which is what I'm looking for in this problem. Since it's find the rate of change to the top of the ladder, so how fast is that moving downward? When the bottom is 7 feet away. So I actually know that this is 7 feet here for this, this value of x. Got a few different ways we could go about this. First, let's just go ahead and make the observation that we're going to be using the Pythagorean theorem. Our formula that's going to govern this entire problem is that x squared plus y squared is 20 squared. Just following this right triangle right here. We're going to kind of use that twice. Once I'm going to use it over here on the side, because I know that x is 7. And so I can plug that into this formula real quick, and I can get that y is going to be the square root of 20 squared minus 7 squared. And this comes out to be, we'll round it to 18.7 feet. This is a piece of information that I'm going to need in this problem that's not really given. You know, so it's like a little side algebra we had to do to figure out that value. But now we can go ahead and jump in and start solving this thing. So once again, as with all the related rate problems, I'm going to find the derivative of this with respect to t. So that means that the derivative of x squared is 2x. But because it's with respect to t, it gets a dx dt. Plus 2y dy dt. The derivative of 20 squared is 0. Well, we've said before that what we're looking for here is the value of dy dt. So I might as well just get it by itself. If I take this over to the other side, I'll have negative 2x dx dt. And then I would divide by 2y to get dy dt by itself. And then if I plug in the values that I know, I've got negative 2 times my x value is here. I've got dx dt here. And then 2 times my y value here. And this all comes out to, I'll put dy dt again, is negative 0.75. And this is in feet per second. Which is almost all the problem. Except that we've got one more piece here. How fast is the area changing when the bottom of the ladder is 7 feet away? So at the same time, I want to know how fast this area is changing. Well, this kind of starts the problem over again. I know that area of a triangle is 1/2 base times height. But for the way I have this set up, the base is x and the height is y. Well, if I want to know how fast the area is changing, that's dA dt, which pops up if I take the derivative with respect to t. And that's going to be 1/2 times, once again, a product, right? X times y. So I get a product here. This is going to be x times the derivative of y plus y times the derivative of x. Looks quite complicated at this point, but we know all these values. So really we're almost done at this point. If I start plugging in what I know here, I've got 1/2. I'll leave my brackets on so it's easy to follow. I know the value of x is 7. dy dt, I actually know that too because I just found it a few minutes ago, right? So I've got negative 0.75 I can put in there. And then I've got plus y, we found up here, 18.7. And that's multiplied by dx dt, which was given early on here, 2 feet per second. Multiply all that out, and it comes out to be negative 16.1. And that's square feet per second. Another speed of area. There you go. Related rates. Enjoy.